Hello friends, welcome to engineering tutorial. So here is another question on dot product of vectors or scalar product of vectors. So again we are given two vectors, a vector and b vector, and we have to determine the following: dot product, the scalar projection or the scalar component of a vector onto b vector and b vector onto a vector, and then the angle between a vector and b vector. Okay, so first we have to determine the dot product. Now we know that when a vector is expressed in terms of its x, y and z components, okay, this is a vector and this is b vector. Where ax, ay and az are the x, y and z components of a vector, bx, by, bz are the x, y and z components of b vector. The dot product is simply expressed as the product, the sum of the products of the x components, y components and z components respectively of both the vectors ax, bx, ay, by plus az, bz. So here correspondingly, if we notice a vector and b vector, 3, 2 and minus 1, they are ax, ay and az respectively. 5, 5, 0, they are bx, by and bz respectively. So here it will be 3 into 5 plus 2 into 5 plus minus 1 into 0. So it will be 15 plus 10 minus 0 or plus 0, whatever you want to write. So it is 25, the dot product. This is the dot product. This is the first part of the answer. Okay, second, let us focus on the angle, then we'll go to the projection or scalar component part, okay, because it is somehow related to that. So first we'll determine the angle, then we'll go for the scalar projection. So for determining the angle, we have to follow the basic definition of dot product, which is expressed as a vector dot b vector, a vector magnitude, b vector magnitude or modulus cos theta. This is the basic expression of dot product. So here cos theta can be expressed as a vector dot b vector divided by a vector modulus b vector modulus. Okay, a vector dot b vector we have calculated here, which is equal to 25. So here it will be 25 divided by a vector modulus. So we know when a vector is represented as this, okay, the modulus is expressed as ax square, ay square, az square root over. Similarly, b vector modulus is expressed as bx square, by square plus bz square. This. So here it will be first the root over 3 square plus 2 square plus minus 1 square, okay. Then we have 5 square plus 5 square plus 0 square. So it will be 25 divided by root over of 3 square 9 plus 4 13 plus 1 14, root over of 14, and here it is root over of 5 square plus 5 square, which is 25 plus 25 50. Okay, this. So let us calculate how much it is coming. So it will be 25 by root over of 15 to root over of 14. So it is coming around 0.94491, that is cos theta. That implies theta will be cos inverse of 0.94491. So it's always better to keep a number of decimal places, so the more accurate the result will be. So cos inverse of this much, it is shift cos inverse of 0.94491. So it is coming around 19.106 degrees. Okay, this much. Okay, so this is the result. Okay, so here first we determined that, and then we calculated the angle, okay, which was derived from this expression. So we have got, this is the answer to the third part of the question. Now the second part, which is scalar projection or scalar component. Now we have already discussed the concept of scalar component, that suppose there are two vectors, let's say okay, A vector and B vector. So the scalar component of A vector onto B vector, that is expressed as, first we'll draw a perpendicular from that particular vector. The angle between them is theta. So this is the scalar component of A vector onto B vector, this. And similarly the scalar component, this is A vector onto B vector, okay, A cos theta. Similarly the scalar component of B vector onto A vector. So for that we have to draw a perpendicular from B vector to A vector, okay. So it will be something like this, okay. Here the angle is theta, and then this is the scalar component, B cos theta. This is the scalar component of B vector onto A vector, okay, B vector onto A vector. This is the scalar component. So here the scalar component of A vector onto B vector, which is A cos theta. So here A is A vector modulus this. Now cos theta is expressed as this, A vector dot B vector by A vector modulus by B vector modulus. So here it will be A multiplied with cos theta, which is A vector dot B vector by A vector modulus B vector modulus. This will get cancelled, so it will be simply A vector dot B vector by B vector modulus. A vector dot B vector, the dot product simply we have calculated, that is 25, and the B vector modulus we calculated, which is root over of 50, isn't it? B vector is root over of 50. Okay, this. So here the result will be 3.535. Okay, 3.535. So obviously it will be a scalar value. Okay, that is the scalar projection of A vector onto B vector. Similarly, the scalar projection of B vector onto A vector, that is expressed as B cos theta. So that will be B vector applied with A vector dot B vector by A vector modulus B vector modulus. Okay, this here it is modulus. Okay, B vector modulus will get cancelled out, and will be simply A vector dot B vector by A vector modulus. So here it is the dot product in the numerator, which is 25, and here A vector modulus we have calculated, it is root over of 14. Root over of 14. So here the result is so it is coming around 6.681. 6.681. Oh yes, that. Okay, so these are the two values, which is the second part of the question. Okay, this one and this one. So first we determined the dot product, okay, the first part. Then we determined the angle, that is 19.106 degree, that is the third part. And then we determined the scalar projection or component of A vector onto B vector and B vector onto A vector here, which is the second part of the question. Okay.